welcome to this Centremaps video on aerial imagery and actually a range of other data sets that we're able to bring thanks to our partnership with Bluesky. We've been working with Bluesky for 20 years plus now. Ralph's with us today.
Thanks, Andy. We're one of the leading suppliers of aerial imagery, one of the largest aerial survey companies in the UK and Republic of Ireland, but we actually operate in the US and various other areas of the world now. Aerial imagery is, I think, what you'd probably call our bread and butter. However, we do lots of other products nowadays, so the business is very much split between what we call our product side of the business and our project side of the business, and that's where we might start to talk a little bit more about LiDAR and some of the other aerial survey products we do.
When we started 20 years ago, it was probably a new thing, really, the idea of being able to go into a browser maybe and pan around the country or your GIS and seeing the data. It's quite a new concept, and I thought it was worth just taking a moment to look again at actually how do you get that seamless layer of imagery, because it isn't magically captured in that.
So aerial photography's been around for 150 years, but in a very different way. I think we started seeing true national seamless data sets in the sort of mid to late 90s, but with the advent of the digital cameras, which came around in sort of 2003, 2004, that completely changed the way aerial photography was captured, produced, as you'd expect, and that enabled the market really to move on from film, analogue photography, and it increased the efficiencies of what we were doing, but also, some might argue, actually increased the flexibility and the quality of the outputs as well. The mosaics, you alluded to the mosaics there, so actually the aerial photography we capture is still framed, so we capture millions of individual frames, and all those frames have to be made map accurate, so they have to go through a process called auto-rectification. Nowadays we actually have enhanced that process, and we do a process called true auto-rectification, and what that means is we have a true vertical view of the buildings and all the features, so you're looking vertically down on every single feature. In the past, some of you may remember that actually you'd be able to see some building lean, you could see the sides of buildings, there's certainly taller buildings. It created a bit of an issue where people were trying to map, for example, if you were trying to create planimetric mapping, actually you had some obscuration of the ground because of the building lean. Nowadays all of that imagery is captured with this true ortho technique, so it's all truly vertical, and all you ever see is the plan view of all the features. So that's a big advancement, and that's done to the national data set. So you've got all these individual images, they then have to be stitched together in a process, a mosaicing process, quite a complex process, but nowadays some of that process is automated. You have to think about being sympathetic with the colours of the imagery, if it's captured at different seasonal times or different times of day. Also, you have to think about the differences in the radiometry of the imagery as well, and make sure that matches across the whole of the mosaic. You're never going to get a truly seamless image because of those differences, but actually we do a lot of work to ensure we have as seamless data set as possible.
Yeah. One of the other things we've noticed over the last few years is that the rate of capture of repeating coverage has really stepped up, and I think it's what are we up to now, 3 year cycle?
2 from this year, so that is very much down to the technology as well. As the technology improves, the efficiencies improve, we're able to capture larger footprints on the ground with each shot we take. The aircraft we use are more efficient, faster. The cameras can keep up with the aircraft, so previously if you had a really fast aircraft, you'd struggle with the shutter speed of the cameras, but that is now caught up as well. So we're able to capture probably twice as much imagery in the same time as we were able to 10, 15 years ago, and that makes a big difference to those efficiencies. So
I guess that's particularly incredible as you started at perhaps 25 centimetre and now you're even at 5, so it's that multiplication as well.
Absolutely, yeah, that's absolutely right. So now we were at that 25 centimetre resolution, and the national data sets are now captured at 12.5 centimetres, so all of that imagery is available for the whole of Great Britain and Republic of Ireland at the 12.5 centimetre GSD. As you allude to there, we're also capturing lots of the urban areas at 5, 4, even 3 centimetre resolution in some areas, so the amount of detail you can get out of that imagery is significant, and what that extra detail does is it expands the number of applications you can use the imagery for, and it gives users far more scope. The more detail you can see, the more applications there are.
Yeah, it's quite actually, it sort of permeates through as well, and even when you view and get the 25 or the 12.5, you can recognise that the capture rate's been that much higher.
Sure, yeah, definitely.
So that's the aerial imagery, and we always find it really adds a lot of context. You know, quite often talk about it alongside OS mapping being in its own right in things that maybe don't get mapped, like surface types,
Yes.
or roof structure and detail like that. So
Yeah, and that's a really key point. I think as we're seeing more AI, machine learning applications coming online, high quality, high resolution aerial imagery is really becoming more and more prevalent in the market. Aerial imagery is providing far more value to users in the market, so extracting features from aerial photography is something that's going on a lot at the moment.
Right.
Whether that being roof shapes, roof materials, whether we're looking at land use, land cover data, that all requires a really high level of quality in the base data sets. Right. The demand for that aerial photography is growing significantly just at the moment.
So they're manipulating that same data into suit those different applications.
Yeah, exactly that. Yeah.
And I guess the other thing we've seen with your data sets, the kind of branch out into additional capture types alongside the visible band in the aerial imagery.
All of the aerial imagery is actually captured with 4 bands, so
right.
RGB and near infrared band as well, and we produce a colour infrared layer as standard as one of our core data sets, and not as widely used as some of the other data sets we produce, but actually it has some really specific applications around vegetation health, vegetation classification. The near infrared band can also be used for looking at land use and that sort of thing as well. So the applications are more specific, so you don't tend to see as much demand, but actually they're really useful in their own right. And over and above that, of course, we have our LiDAR capability as well. So we have a number of market-leading LiDAR sensors. LiDAR's been around a long time, but again, over the past few years, the adoption of LiDAR more broadly has really led to an explosion in the use of LiDAR data, and that's a lot to do with the software enabling people to really exploit the LiDAR point clouds as well as the traditional gridded terrain data that you'd get. So we're doing a lot of projects with the LiDAR sensors at the moment for all sorts of different applications, whether that be overhead power line, vegetation encroachment, looking at coastal erosion. Archaeology is another big one for the LiDAR. Local authorities, public sector, who want to see their features in a lot more detail. Certainly the applications of LiDAR are growing exponentially.
Yeah, with the interest from our customers, wherever it's available, they're very, very keen. I think for us, quite a lot of our customers are working on a specific site and just understanding the site slope and any drainage and things like that. That
Sure.
When you're getting down to that kind of 50 centimetre interval data especially is an incredible...
It is, and we're able to actually capture LiDAR with 2 to 3 centimetre or 20 to 30 millimetre vertical accuracy, and for civil engineering applications that's significant. Whereas previously they might have to go on site and site survey to get that sort of level of accuracy, we can now go out and capture large areas of ground, large geographies in one single flight and provide data at that sort of resolution, that sort of accuracy. The LiDAR technology, as you'd expect, is growing very fast, and it's enabling us to capture more and more data in one single flight, a higher level of accuracy in one single flight as well.
Yeah, and I'm sure probably people might have seen in the press anyway, the kind of multi-sensor stuff you're starting to collect now, particularly in urban centres. That's
right, yeah. So you may have seen our Metro Vista product, so the Metro Vista data sets, which we actually use the Leica Citymapper 2 sensor. So the Leica Citymapper 2 enables us to capture nadir or vertical aerial photography in combination with oblique imagery, so 45 degree, 4-directional oblique cameras as well, including a LiDAR sensor. So true hybrid sensor that enables multiple capture of different data sets in one flight, and that's clearly huge efficiency gain for both customers and ourselves, but it also enables us to create some superb downstream products like very accurate 3D textured mesh data sets for city areas, which are becoming more and more prevalent in the market at the moment. It's a phrase that gets banded around a lot at the moment, but digital twins, smart cities, all of those type of applications need a great geospatial base to work from, and something like a 3D textured mesh model really provides that geographic context or that geographic canvas for those applications.
Yeah, and I guess the software to make use of and really get the value from that data is all rapidly developing, as well as the benefits of got these data cloud streaming that people don't have to take a multiple terabyte set of data to be able to use it. They can actually start pulling it into the application.
Yeah, that's right. So I think one of the key challenges with these sort of data sets previously has been the ability for people's software to actually ingest that data. It's huge in its size, but it's also technically complex. More recently, some of the big GIS vendors, some of the big software companies have worked extremely hard to enable those data sets to be ingested far more efficiently, far more rapidly, and what that's allowed our customers to do is derive a lot more value out of those data sets and really start to use them in anger in a lot more of their applications. So take a local authority, for example. Previously they could have only dreamed of having a citywide 3D mesh data set and use that in their corporate GIS system. Now that's a reality, and it's something that's being adopted far more broadly.
And sort of go back again to that area and dream we talked about at the start, that's something else that we can now stream and talk about packages for that. So it's quite often people are dealing with discrete sites, but actually if you're trying to work on a broader understanding and working across an area and just want to be able to dip into the data as and where you need it in your GIS, that streaming option's now something that there's actual license models.
Yeah, absolutely. You can't get away from software as a service, data as a service nowadays, and we've worked really hard to stand up all our data sets on robust data as a service models, so people can access our national data sets straight into their applications. So regardless of whether they're using CAD or GIS or design packages, they can access that data nationally for one monthly fee or one annual fee and use that data directly in their applications. So that's a bit of a change, but now it's a reality as well. That data is immediately available.
Thanks, Ralph. It's been really interesting. If you want to find out anything more about the data sets, do come and have a look at the interface. You can find what's available in different locations around the country, but also give us a call and have a chat about any challenges you might think the Imagery can help or stream it into your application.